All right, happy Friday, everybody. So today we're going to do the applications of sequences and series. We're going to start out on the note sheet that you have handed out to you by the wonderful and talented Mr. Wendling. Okay, a little different take on problems that we did yesterday. Okay, so now here we need, in order to find the sum, we need to have our sum, the number of terms, the first term, and the last term. Okay? So we know we have the sum. It's negative 50. That's this part right there. This is what it's equal to. Okay? I don't know the number of terms. Okay? So that's just going to have to be n minus 1 plus 1 is going to be n. Okay? So let me put that in a different color here. Let's go with, we'll stick with green. So we're going n there. Okay? Actually, let's go red. Yeah, red. Woohoo! Changing my mind. Okay? My first term, I take, and I can find my first term, remember, by taking my lower limit and plugging it into my rule. So 5 minus 5 is 0, so my first term is going to be 0. My last term, I find by taking my upper limit and plugging that into my rule, but ruh-roh, I gotta leave it like that. Okay? So now we can go to our sum formula. Remember, our sum formula from yesterday was the number of terms divided by 2 times the sum of the first term plus the last term. Yeah, buddy. Okay? So I know then that my sum here is negative 50. I know that my number of terms is n. I know that my first term is 0. And I know that my last term is 5 minus 5n. So if I get rid of that fraction and I multiply both sides by 2, that gets me negative 100 equals n times 5 minus 5n. Okay? Because this right in here, okay, that, when I add 0 to it, it stays the same. Okay? Distribute that n. Why not? Then, because now I have a quadratic, I'm going to get everything onto, in this case, I'm going to go everything onto the left side because I need to get it equal to 0. Okay? So now I could factor out a 5. Two numbers that multiply together to be negative 20 and add together to be negative 1 are negative 5 and positive 4. Then I set those equal to 0. So n could be 5 or n could be negative 4. But it's hard to have negative 4 terms in my sequence. Okay? So this one gets kicked out, and then just left with the number of terms in my series is 5. And that's what I'm looking for, solving it for n. Okay? Same type of problem, just a little more algebra involved in it. Okay? So here is the first problem on your, or the second problem I should say, on your worksheet. Okay? A field house has a section where the seating can be arranged so the first row has 3 seats, the second row has 7 seats, the third row has 11 seats, and so on. Okay? So we're at 3, and then 7, and then 11, and so on and so forth. Okay? Well, that's arithmetic because we're always adding 4, and we keep on that pattern. We keep adding 4 on that pattern. That's arithmetic. There is sufficient space for 30 rows in this section of the field house. How many seats are in the last row of the section? Okay, so we've got 30 rows, so that means we're looking for the 30th term in that sequence. Well, the first term of that sequence is 3. The common difference is 4, and the number of rows in that section is 30. So we get that. So then that's going to be 3 plus 4 times 29. 4 times 29 is 116. So in the 30th row, there are 119 seats. Now, because we're dealing with word problems, we need to have labels in our answers. Okay? Then it goes on to ask, how many total seats are there in the section? Well, there's 30 rows. We remember to find the total number of or the sum, basically. So anytime you see total, you should think sum. So I need the number of rows. Well, there's 30 rows in that section. I need how many seats are in the first row. Well, there was 3 seats in the first row. And I need to know how many there are in the last row. That's what we just calculated at 119. So the sum then of the 30 rows of seats in the field house are 30 divided by 2 times 3 plus 119. So that's going to be 15 times 122, which if I do that on the calculator, I get 1,830 seats in this section in the field house. Okay. Production line is improving its efficiency through training and experience. If the number of items produced in the first 4 days of a month are 13, 15, 17, and 19, respectively, project the number of items produced on the 30th day of that month. Well, we started with 13, then they went to 15, then they went to 17, then they went to 19, and so on and so forth. So, let's figure out that the 30th day of the month, A sub 30, is going to be, using my recursive formula, A sub n equals A sub 1 plus D times n minus 1, tells me then that my first term was 13. My common difference is 2. There's 30 days in this month. So that's going to be 13 plus 29 times 2 is 58. 13 plus 58 is 71. So there are 71 items, really jumping up the efficiency in that particular factory. Okay. Project the total number of items produced. Again, I need the number of days in that month. There were 30. I need how many we produced on the first day. There were 13. I need to know how many were produced on the last day. There were 71 items produced on the last day. So the sum of the first 30 days of that month is going to be 30 divided by 2 times 13 plus 71. So that's going to be 15 times 84. So that is 1,260 items produced that month. Okay? So, today you have the 12.2b homework is due. Please hand that in to Mr. Wendling or put it in the orange folder that he has. And then yesterday you got the yellow sheet, okay? And the yellow sheet is will be due on Monday. You got that yesterday in class. Have a good weekend.